Hey everyone, welcome back. Get ready, because we're about to do a deep dive into a cosmic mystery that's got astronomers scratching their heads. I mean, really baffled.
It's a real head scratcher.
We're talking about blazars.
Huh.
You know, those crazy, intense jets of energy blasting out from supermassive black holes.
Yeah, they're pretty wild.
But here's the thing. There's one particular blazar called BL Lacertae, and it's acting like a cosmic chameleon, changing his appearance and just totally defying like everything we thought we knew about how these things work.
It's really throwing us for a loop.
So we've got this fascinating article from Astronomy and Astrophysics that lays out all the observations, so let's get into it.
Yeah, let's dive in. What's really intriguing here is that this BL Lacertae, it's showing us that our whole blazar classification system might be, I don't know, like based on just these temporary snapshots rather than any real fundamental differences.
Oh, okay, I see what you're saying.
Yeah, it's like we've been, categorizing butterflies based on like the color of their wings, but only when they land on a flower, we never realized they could change colors while they're flying around. You know what I mean?
Yeah, that's a great analogy.
Thanks.
Okay, hold on. Let's rewind a bit for those of us who maybe need a little refresher here. What exactly are blazars, and why are they so mind-bogglingly amazing in the first place?
All right, so picture this. You've got a galaxy with a supermassive black hole at its center. We're talking millions or even billions of times heavier than our sun.
Wow, that's huge.
Right, and this black hole, it's like a cosmic engine just pulling in all this matter and then spitting out these unbelievably powerful jets of particles from its poles. And get this, these jets are traveling at nearly the speed of light.
Near the speed of light. Seriously. I'm trying to wrap my head around that kind of speed. It's like going from Earth to the moon in like a second or something.
Well, not quite that fast, but you're getting the idea. These blazars, they're like nature's particle accelerators just pumping out energy on a scale that's almost impossible to even comprehend.
Yeah, it's hard to even imagine.
And that's why scientists are so fascinated by them. They're like a window into some of the most extreme physics in the entire universe.
That's incredible. All right, so we've got these cosmic powerhouses, blasting across the universe. Now tell me about BL Lacertae. What makes it the star of the show today? Besides the fact that it apparently has an identity crisis.
Well, the story starts back in 1929 when astronomers first spotted BL Lacertae. They thought it was just a variable star, within our own galaxy, like a cosmic firefly kind of blinking on and off.
Okay, I can see that.
Yeah. But later observations, oh boy, they revealed something mind-blowing. This star, it was actually about 900 million light years away.
What? 900 million light years? That's way beyond the Milky Way.
Oh yeah, far beyond.
So we're seeing it as it was 900 million years ago. It's like we've got a time machine pointed at this thing.
Exactly. And that distance also means that the energy we're seeing from BL Lacertae is just enormous. I mean, to appear so bright from so far away, it must be unbelievably powerful.
So this isn't just some distant flicker. This is a cosmic beacon shouting at us across time and space.
You got it. It's mind-blowing.
So let's get to the heart of the mystery here.
Yeah.
You mentioned a classification system for blazars. Can you break that down for us? Like, how does it work?
Sure. Traditionally, we've divided blazars into two main categories. You've got the flat spectrum radio quasars, or FSRQs.
FSRQs, okay.
Yeah, which are incredibly bright and emit lots of radio waves.
That's good.
Then you've got the BL Lacertae objects, or BL Lacs, which are a bit more, I guess you could say, subdued in their radio emission.
Okay, so are these two types of blazars like totally different beasts, or are they more like cousins on the same family tree?
That's a good question. It's more like they're different breeds of the same species. They both have those powerful jets, but the details of what's happening inside and what we actually see from Earth can vary quite a bit.
I see, okay.
And within the BL Lac category, we have even more subdivisions: HBL, IBL, and LBL.
Wait, so many categories?
Yeah, we categorize them based on their energy spectrum. It's kind of like analyzing the light from a star to figure out what it's made of.
Oh, okay, so like a cosmic fingerprint.
Exactly. Each type has a unique fingerprint.
That's really cool. Okay, so BL Lacertae is a BL Lac, which makes sense given its name. But it's not playing by the rules, right?
You got it. BL Lacertae was initially classified as an IBL. But get this, observations from 2020 to 2023 show it rapidly shifting between all three BL Lac categories.
Whoa, seriously. It's like jumping between categories.
I know, right? One moment it looks like an HBL, then it morphs into an LBL, then back to an IBL.
So it's like a cosmic quick change artist.
Yeah, it's changing its identity faster than a chameleon in a disco.
Whoa, that's crazy. I mean, how can something that far away change so rapidly? What's going on?
That's the million-dollar question, and that's where the real mystery lies. To understand these changes, we need to dig into what we're actually seeing when we observe a blazar. Like, what's happening at a fundamental level.
Okay, I'm ready to dig in. Let's get to the bottom of this.
All right, let's do it.
All right, so we've got this blazar behaving badly, flipping between categories like it's trying on different outfits. What are some of the theories that scientists are exploring to explain these, like, rapid-fire changes?
Well, one idea focuses on the jet itself, that powerful stream of particles shooting out from the black hole. Imagine a fire hose blasting water at incredible pressure.
Okay, yeah, I can picture that.
Even a slight wobble in the nozzle can send the stream whipping back and forth.
Oh, I see. So you're saying the jet itself might be wobbling, like it's not perfectly straight?
Exactly. It's called precession. Think of like a spinning top. As it slows down, it starts to wobble, and that axis of rotation starts to shift.
Right, yeah.
So if the jet of BL Lacertae is precessing even slightly, it could change the angle at which we're seeing it from Earth.
I can see how that could, like, make a difference in our observations. Is that wobble something scientists can actually measure?
Well, that's what they're trying to figure out. It could be a very subtle shift, or it could be something more dramatic.
I see.
And it would have a huge impact on how we interpret the light we receive from the blazar, potentially explaining this whole category jumping act we're seeing.
Okay, that makes sense. So that's one possibility. What other theories are out there?
Another idea focuses on the accretion disk, that swirling disk of gas and dust that's constantly feeding the black hole. You could think of it like as the black hole's cosmic buffet.
Okay, I like where this is going.
Yeah.
So how does the black hole's eating habits tie into all of this?
Well, imagine adjusting the fuel flow to a rocket engine.
Okay.
The rate at which matter falls into the black hole can actually influence the power and direction of the jet.
Oh, interesting.
If the accretion disk gets disrupted or changes its feeding pattern, it could trigger these variations in the jet's behavior that we're observing.
So it's like the black hole is having a cosmic indigestion moment, and that's causing the jet to sputter and change direction.
That's a great way to put it. Those changes in the accretion disk could absolutely explain some of the variations we're seeing in BL Lacertae's light output and, why it's flipping between categories.
Yeah.
But we're talking about changes happening on a time scale of days or even hours.
It's incredibly fast.
Wouldn't that require some pretty intense and sudden shifts in the accretion disk?
Yeah, you're right. The time scale is a crucial piece of the puzzle here. The changes in BL Lacertae are happening incredibly fast, which is a real challenge for any theory to explain.
Absolutely.
So we need a mechanism that can account for both the changes themselves and the lightning-fast speed at which they're occurring. It's like trying to solve a Rubik's Cube while it's spinning.
Exactly. And that's what makes this so exciting. It's pushing the boundaries of what we know about black holes and the extreme environments they create. We need to find a theory that can explain both the what and the how fast of this cosmic conundrum.
Right. It's going to explain it all.
It does.
So are scientists leaning towards one of these theories, or are they still wide open to other possibilities?
It's still very much an open question. Each theory has its own strengths and weaknesses, and right now the data isn't quite enough to definitively pick a winner.
I can imagine the debates happening right now in astrophysics labs around the world. I'm picturing whiteboards covered in equations and coffee stains as astronomers try to piece together this cosmic puzzle.
Oh, I'm sure there are some pretty lively discussions happening.
Yeah.
But that's what's so great about science. We're constantly questioning, exploring, and refining our understanding.
To process.
It is. And BL Lacertae is giving us a fantastic opportunity to do just that.
Yeah, it's really pushing us to think outside the box. Speaking of exploring, what are the next steps in unraveling this mystery? What kind of research are astronomers planning to do to get more answers?
Well, the key is to gather more data. Imagine being able to point the most powerful telescopes in space at BL Lacertae and capture those changes in real time. I'm talking about telescopes like the Neil Gehrels Swift Observatory and Nustar.
So it's like we need to watch this cosmic chameleon change its colors and then analyze those changes in detail.
Exactly. By observing BL Lacertae across the entire electromagnetic spectrum from radio waves to gamma rays, we can get a much more complete picture of its behavior. It's like getting a 3D scan of the blazar instead of just a flat snapshot.
That makes a lot of sense. With more detailed observations, scientists can test their theories with much more precision. Maybe they'll even discover something completely unexpected in the process.
That's always a possibility in astronomy. Every time we look deeper into the universe, we find something new and awe-inspiring.
It's true. All right, so we've got this incredible object, BL Lacertae, challenging everything we thought we knew about blazars. But this isn't just some isolated case, right? I mean, if BL Lacertae can switch categories like this, what does that tell us about other blazars out there?
That's a great question, and it gets to the heart of why this discovery is so significant. If BL Lacertae is doing this, it's entirely possible that other blazars are too.
Oh,
And that would mean that our current classification system might be way too rigid, like we're trying to fit square pegs into round holes.
so we might have to rethink how we categorize these objects entirely.
It's definitely a possibility. And that's incredibly exciting. It means we have a chance to learn something fundamentally new about these incredibly powerful objects.
So it's not just about understanding BL Lacertae, it's about potentially rewriting the book on blazars as a whole.
Precisely. And it shows how even something as seemingly obscure as a distant blazar can revolutionize our understanding of the universe.
I love how science can be so surprising. But before we get too carried away with rewriting textbooks, let's focus on what this means for our listener. Why should they care about a blazar billions of light years away? What's the big takeaway here?
You're right. Let's bring it back down to Earth.
Yeah, that's a great question. Why should any of this matter to someone who's not like, an astrophysicist? It's cool to think about, black holes and cosmic chameleons, but how does this blazar mystery connect back to us here on Earth?
Well, I think there are a few really important takeaways here. First, BL Lacertae, it reminds us that the universe is full of surprises. Just when we think we've got things figured out, something comes along and throws a wrench in our cosmic toolbox,
Right. It's like we're constantly learning.
Exactly. It's a good reminder to stay humble and be open to new possibilities.
So even in the vastness of space, there's still this sense of mystery and wonder. We haven't figured it all out yet.
Not even close. And second, this discovery shows us the power of curiosity and asking questions. Think about it. Someone looked at a seemingly ordinary star and asked, what if that's something more?
Right.
And that simple question led to this mind-blowing discovery that's changing our whole understanding of the universe.
It's like a reminder that the biggest discoveries can start with the simplest questions. It makes you want to go outside and stare at the stars and wonder what secrets they hold.
I do that all the time.
Me too.
And finally, I think BL Lacertae highlights the importance of collaboration. It took a team of astronomers, physicists, engineers, and countless others working together to make this discovery.
Yeah, it's a team effort.
It really is. It's a testament to what we can achieve when we combine our knowledge, our curiosity, and our passion for exploration.
It makes you realize that science isn't just about facts and figures. It's about people working together to solve puzzles and unlock the secrets of the universe. It's a pretty inspiring thought, actually.
It is.
Yeah. So even though BL Lacertae is billions of light years away, its story has these lessons that resonate with us here on Earth. It's a story about the power of curiosity, the importance of collaboration, and that ever-present sense of wonder that drives us to explore the unknown.
Beautifully said.
And it's a story that's still unfolding, right? I mean, astronomers are going to keep observing BL Lacertae, trying to understand its strange behavior. Who knows what other surprises this cosmic chameleon might have in store for us?
Exactly. There's still so much to learn, so many mysteries to unravel, and that's what makes astronomy so captivating. It's a never-ending journey of discovery.
Well said. And I think that's a perfect note to end on. To our listeners, we say this: keep looking up at the stars, keep asking questions, and never lose that sense of wonder.
Yeah.
The universe is full of surprises.
Yeah.
You never know what incredible discoveries might be just around the corner.
Until next time, keep diving deep.